Since coding is fairly new to some of you in the class, and it may be new to more than some of you, I thought that we'd take a little time here in this lesson to do a coding primer. And from this point forward, actually in the next couple lessons, we're going to be doing a little more coding, a little more scripting, and a little more writing in Vex. So this will be a pretty good introduction to code if you haven't already familiarized yourself with how to write Vex in Houdini. When you're making an attribute wrangle and you're writing in Vex there, what you're really doing is creating a small miniature little program that just runs on that node. So let's talk about what exactly a program is. And really, the most simple way of thinking about what a program is it's just a collection of tasks that are performed in order. And that's it. They're just steps for doing something. If you think about your life as a series of tasks that you do, you can break that down into simpler and simpler components until you can basically make a program to do something kind of challenging or significant. But even something basic like making a piece of toast, you can break that down, right? So you would have some function that goes to the bread box, and then another one that opens it up, and then another one that retrieves a piece of bread, then another one that puts the bread in the toaster. Of course, you need to open the toaster first, and then you need to set your desired darkness or toasting setting. Then you need to wait. Then you need to open it up and then get the toast out, and etc., etc. And if you come at it with that mindset about what a program is, and you think that it's really just a series of breaking down tasks into smaller and smaller steps until you have the components really clearly built up, it will make things much, much simpler for you. There are really just a few rules in terms of the general reading and writing of code, and knowing these will help clear up a lot of issues that you may experience later on. The first is that code is read line by line, top to bottom. That's how the computer reads it, and when you're going through code and you're trying to understand it, that's how you should read it as well. So you go line by line, top to bottom. Now, every line, every complete statement is going to end with a semicolon in Vex, and that's how you know when the statement is actually ended and you're at a new line. The exception to this rule about line by line is when you get into loops and conditional statements. So what a loop does is it allows you to redo a certain block of code over and over again instead of having to rewrite that same block of code 5, 10, 15, 1,000 times. You basically write that block of code once, and you give the compiler a little information that tells it when you get to this end of the block of code, go back to the beginning of that block and do that whole section all over again until you reach a certain condition that I've decided ahead of time must be set. And then once you've reached that certain condition, keep on going back to the next line and then just keep reading line by line. Conditional statements, which you would know as an if-then statement, basically tell the compiler, look for a certain set of conditions to be met, and if that condition is met, then read the next lines that are inside this block of code. Otherwise, just skip it and move right on down. And that's really it in terms of the basics of reading code and understanding how it's flowing. The next thing that I wanted to talk about, and the last thing, is that you'll see a lot of times in code these double slashes. And what those are comments. And you should, especially when you're just getting your feet wet with code, you should be putting comments all over the place and documenting what you're doing, because it's going to be really helpful to you because you're not going to remember what you did in the past or why you even did what you did. So it's great to do lots of comments, and you'll start to see other people's code and see where they're putting comments in there as well. You may remember variables from your elementary math classes and algebra classes, and they're really not much different when it comes to coding. They're just placeholders. They're placeholders for information. And all they really do here is store data and save that data in your computer's memory. So that's it. Just remember that a variable is just storing data, and it is reserving space in your computer's memory for that data. Now, one thing to know about variables is that because they are reserving space, you have to actually declare ahead of time what type of variable it is that you're defining, because the computer needs to know how much space that it has to reserve, and different types of variables have different sizes associated with them. and amounts of memory that need to be reserved. And this is all based on computer efficiency and memory management. So you'd want to be pretty clear about what it is you need when you're defining these things, especially if you're making some very, very heavy program. Variables can be initialized, and what that means is when you define the variable, you can also give it a value. You don't have to initialize a variable. You can just define the variable just with its type and name, in which case it will have a default value, or you can actually assign it a value when you define it. As an example, we have here a variable called myVariable. It is a float, and we have said that that is equal to 10.75. We'll talk about attributes in just a minute here, but what you do need to know is that variables and attributes are not quite the same thing. They perform very, very similar functions, but variables are only valid in this block of code here, and they don't persist with your geometry, meaning as soon as this code is done being executed, they're deleted from memory and you don't have access to them anymore, whereas attributes will persist on your geometry and can be recalled later. On this slide, I've listed a bunch of common variable types that you'll find working in Houdini. These are certainly not all of the types of variables out there, but these are the ones that you're most commonly going to use, especially as a beginner and intermediate coder and writer of VEX. So just to go over these pretty quickly, an integer is a whole number without any decimal places, meaning a number like 3, 27, 105. A float is a more precise number, meaning it has decimal points, 1.89734. Another one would be 5.42. Anything with decimal points is going to need to be a float. A vector is just a collection of 3 float values, such as position, which has an X, Y, and Z component, or color, which has a red, green, and blue component. An array is just a list of values, and they can be different types of values, but basically it's a way of holding a bunch of different kinds of data together, whether it be a series of integers or a collection of floats, or even a collection of vectors. A matrix is just a grid of values, a grid of floats, and they have 2x2 matrices, 3x3, and 4x4, and they're used all over computer mathematics, such as calculating rotations and transformations, but we probably won't be getting into those too much here. And then finally, a string is just a text variable, so something like happy birthday or hello world, or the name of a piece of geometry would be an example of a string. Attributes are very similar to variables. In fact, for the most part, they have a one-to-one relationship in terms of the types that are available to you. The only real difference in terms of attributes and variables that you need to understand when using Houdini is that variables get destroyed once the block of code is done executing, but attributes persist on your geometry. So they stay with your geometry up until the point that you tell your geometry to delete the attribute, or some sort of operation happens in Houdini that ends up blasting away your attributes anyway, such as converting something to a volume. You might not be able to preserve point attributes at that point. So that's the one piece to really remember, is that attributes persist. The other thing to know about them is that when we do access them in VEX, we need to use a special notation to do that, and that is using this @ symbol. So for instance, when we are trying to define attributes in VEX, we use this @ symbol, and you can see I have integer at my attribute, float, f, that's an f for float, at my attribute, v for vector, s for string, etc. And these are explained in the Houdini documentation as well. To create an attribute, all we need to do is write a declaration, like I, standing for integer, and then the @ symbol, and then the name of our attribute. And we can assign a value, or if we don't, it just gets a default value. Once an attribute has been defined or already exists, you no longer need to use that signature in front of the @ symbol. And here's a couple examples that we can look at. So
In the first example, I'm defining an attribute. I'm saying that I have an integer attribute called my attribute, and it's going to be equal to 9. And just to kind of show you how this works, I'm defining a variable here called x and setting that equal to 10. And now I want to change that value of my attribute. So I don't want it to be equal to 9 anymore. I want something new. And all I need to do is say at my attribute plus equals x, meaning it's equal to 9 plus the new value of x, which is 10. So it will be equal to 19. And notice in this example that I don't need to use the I in front of the at symbol once it's already been defined. Example number 2 would be something where we're establishing some value that we want to put into the attribute. In this case, we're saying we want x to equal to 10. And now because that attribute doesn't already exist, I do need to use the I in front of the at symbol here because I'm creating this right now. So I'm saying I at my attribute is equal to x.
Functions are predefined blocks of code that can be called by name. Essentially, a function is just a group of code or a task that you can define ahead of time, and instead of writing the 10, 20, or 50 lines of code that made up that function, you simply call the function by its name and you input the parameters that that function needs to execute, and then it simply executes that function and either performs its task or returns some value. Now, just like variables, functions need to be declared, they need to be defined, and they need to define the return type, if they even return anything at all. It is possible to have functions that don't return anything, simply perform a task, and those types of functions are called void. Here's an example of a function. The name of the function is called myFunction. It returns an integer value, and we see that it has two parameters. It takes an integer parameter called a and an integer parameter called b. Now we use these brackets to define what happens inside the function, and you see that I have a comment here that says the code to execute goes here. So we would put whatever it is that this function does. Maybe it adds 2 to the value a and then multiplies that by b, and then we simply return a, or we return x, or we return some other integer. But that line that says return, that is what the function needs to do. That is the value that gets returned and can be stored as an integer. Loops are great because they allow us to do repetitive tasks inside code. We can have blocks of code that will execute numerous amounts of time and just hang there and keep going and going and going until they reach some sort of condition that causes them to exit and then begin reading the code in a regular fashion from top to bottom again. We can use them to iterate through data, such as performing the same function for each point in a geometry source. We can also use them to perform a function multiple times, such as creating a new primitive in a scene. We could create 10 primitives just by looping 10 times and setting some values there. There are a variety of loops in Vex, such as while loops, for each loops, and do loops, and they all, in a sense, just repeat some sort of code over and over again, but the way you access them and the methodology of using them is different. In general, though, what we have is an initial condition for the loop. We perform some lines of code. We check to see if we've reached a break condition, and then if we reach that break condition, we exit the loop. If not, we simply go back to the start of the loop. Here's an example of a very simple loop. It just counts to 10, and then it leaves. So we start off with an integer, which has a value of 0, and we start this while loop. So we say while, and now we're checking. This is our comparison here. While I is less than 10, so that's our comparison. If I ever becomes more than 10, then the loop will break. Now we have this bracket here, and after the bracket, we have our code to execute. And now we're simply adding 1 to the value of I. That's what this plus equal means. It means take I and then set its new value to 1 plus the previous value. So each time this loop executes, I is going to increase. So it'll be 3, 4, 5, 6, 7, 8, 9, 10, and then at that point, it's going to exit. If statements allow us to tell a block of code to either be executed or be skipped entirely. And this is great for efficiency reasons, but it's also great to specify something unique or different that has to occur for this block of code to actually be able to execute. So here are some of the conditions that we can use and that we do use. We use these less than, or equal to, equal to. Notice the double equal sign, not a single equal sign. Greater than or equal to, greater than or not equal to. And you might remember some of these from mathematics as well, and they're useful here for computer programming purposes. We can also combine different conditions using these operators here. We have and we have or. So we can say something could be or needs to be greater than 10 and less than 25. Or we can say it needs to be, black, the color black, or it could be red. And if either of those things are true, then we'll go ahead and execute this block of code. And here's how the format looks. We're just looking at something here like executing a block of code if our position is greater than 10. So we start with the if statement, and then in parentheses, we have our condition here. So here we're checking if our position attribute, the y component of that, is greater than 10. Then we have a bracket, and now we have our do something lines of code, and then we just put a bracket on the other end to close that statement. The last thing I wanted to talk about here very briefly are arrays. So arrays are really just sets of variables. You can think of even a vector would be an array. It's a collection of 3 floats. And if you kind of have that basic definition of an array, it's just a collection of other kinds of values and variables. It'll make it much more clear and easy to work with. So arrays do require special methods to add to them, set to them, and extract information from them. We'll get into some of that stuff when we start to use them. Declaring an array is pretty simple. We just say the type of array that it's going to be, we give it the name, and then we have this left bracket, right bracket. You can initialize an array when you create it. So we could say something like integer my array equals, and then we have these curly braces, then the values of the array. So we have an integer, and it has, there's 3 data points in that array, and they're called, or their values are 1, 2, and 3. Arrays can be accessed by index. So if we had that array up above and we wanted to get the 3rd component of that index, we would just call it my array and then bracket 2. So the first index of the array starts at 0, by the way. Numbering starts at 0. So that 3rd component would actually be index number 2. Array values can be set as well, but only if they already exist. So trying to access or set an array index that does not exist will actually produce an error. Setting a value for an array is as simple as just stating the name of the array, calling out the index number, and then saying an equal sign, and then assigning that value right after. We have several different attributes that arrays have. They have a length, which we can use to retrieve the size of the array. We can also have some special functions that are associated with arrays, such as resize, push, and pop. And those are used to change the size of an array.